Hello everybody, welcome to another video. For this video we're going to talk about fractional expressions, and one of the most important thing for this section is actually the concept of factoring. Okay, factoring quadratics. Now this is something that's really fundamental and really underlining before we get to talk about all these fractional expressions. So what I will do for this particular lecture is that we're going to break this into two parts. For problem number 1 to 6, we're going to focus on the first part, which is the quadratic factoring, and then afterwards we'll actually go back and uh, deal with fractional expression as we have it in the title of the lecture. This is super important, and it will take some practice, right? That part is something unfortunately I cannot do for you, so we have to spend the time and the effort on this type of problems so we can get better at it. And the faster and more smooth you are at factoring, the better the rest of your math class is going to be, just because almost every class from now on will have a little bit of factoring here and there, and just kind of sprinkled right in the middle of all sort of different type of problems. So if you have to be stuck on the factoring every single time, if you spend a lot of extra time on it, uh, your solutions are not going to be as smooth as it could have been. So very important topic. Let's get right onto it. Now, starting at this example 1 here, uh, we're going to factor this expression here, and as complicated as this looks, this is a very easy technique, and this will simplify a lot of work, right, in the early calculus section, in the early Calc 1 and Calc 2 classes. You're going to see this technique come in handy, so let's take a look. Right here we have a two-term two-term expression really, and we're going to factor that out. And typically when we say terms here, we refer to things that are multiplied together. So this right here is one term, and that's another term. And it's really kind of separated by that subtraction here. Okay, so I got two terms subtracting from each other. Two-term factor is very easy because all we have to do is to look at what these two terms have in common. And it's not that hard to see that what they have in common in this case is the x minus 3. Once I identify that, I want to go ahead and factor that term out. So I want to take out the x minus 3, and then I'll put a bracket just to indicate what I'm getting what I have left there. But the idea here of factoring is really just another way of saying dividing that term out, right? Dividing the x minus 3 out. So let's see it term by term, right? The first term, I got 2x plus 4 times x minus 3. While I took out the x minus 3, again, that just is another way of saying divide it out. I divide out the x minus 3, so all I have left is 2x plus 4. Minus, come from that, minus. And then similarly, the second term, I have 5 times x minus 3. So take out the x minus 3, I just have 5. So that's what I mean by taking out the x minus 3, right? Factoring out the x minus 3. It's, again, easier to see it sometimes, the other way around, right? If I started with this expression, then I can distribute the x minus 3 back in to get back to the previous expression that we were given, right? So this action of distributing is multiplication, right? That's why when we factor, we're thinking about dividing. Anyways, let's move on to the next part of this, because the next part is actually just a little simplification, so a little rewrite, if you will. X minus 3, and then whatever is inside that bracket, right? I can use the parentheses now. All I have to do is simplify that. So the 4 minus the 5 gave me -1. So I just got 2x minus 1. And there we have it. That's our factor. It's really not that difficult. Very easy operation here, right? Two-term factoring is some of the easiest things you can be dealing with, just because it's really that not that much techniques to this, right? We just have to recognize what they have in common, and we can kind of go from here. Okay, so let's see the next problem. Slightly a bit more, I guess, interesting, or basically just longer, right? This type of expression actually shows up quite a bit in a particular section in your calculus class. Um, I'll leave that as a little suspense for you in the future. So let's take a look at how we're gonna deal with this, right? This is still a two-term factoring because we got this big old term and then this other one, yeah, separated by this addition. Once I recognize that, I then look at what they have in common. So over here, I have a x plus 4 to the 4th power, so I got 4 of these. And then over here on the other side, I got x squared plus 4, 5 of these, right, to the 5th power. Similarly, I got x minus 2 to the 4th power, and then x minus 2 to the 3rd power on the other term. So these are what I have in common, but they don't all have the same number, right? The way you want to handle this is you can take out the smaller power, right? Just because both of them, one has 3, one has 4, you can't take out 4 from both just because the other one don't have enough. You can at most take out 3. So that's what we're going to do. In fact, there's actually one more term here that they have in common. I got a 2 here, and over here I got a 4, and these are kind of in common, right? Because 4 is nothing but 2 times 2. So I got one of these 2's I can take out. So now that I've identified what I have, right, what I have in common, I'm ready to take things out. So I have 1, 2, because I got 1 here and 1 there. I have x squared plus 4 to the 3rd power, because I have, x squared plus 4 to the 4th power, because I got 4 here and then I got 5 here. So take out 4, I have 1 left. Okay, I'll write that down later. And last but not least, I have a x minus 2 to the 3rd power, because I got 3 powers of that here, so 3 copies of that here. And I got 4 copies of that here, so take out 3, I got 1 left. Okay, so I'm going to go ahead and write out all my factors, right, all the things I have in common. And now let's go ahead and write out the rest. Again, I'll use a bracket here just to indicate, I'm collecting whatever I have left. So the first term, I took out all these stuff, right? So I just have a 5 left. I got an x left, and then I got that 1 power of x minus 2 left. So I got 5. I'll just put parentheses for now. Times the x times the x minus 2 to the 1st power. Plus that plus right there. Similarly to the other, the other side, the first term, I got 2 right here, right? I got an extra 2 right there. And I got another power of x squared plus 4. So the second term only has 2 times x squared plus 4, again to the 1st power. That's all I have left. So at this point, I've done my factoring. All I have to do is to clean up a little bit. So I got 2 x squared plus 4 to the 4th power, x minus 2 to the 3rd power. And inside my bracket here, I can multiply the first term, because the first power exponent, right, is just kind of meaningless. So I can multiply out the first term, can clean that up a little bit. So essentially think about 5x, right? 5 times x is 5x, distributing to the x and minus 2. So I got 5x squared minus 10x, right, after that distribution. Same thing with this 2, distribute, and I will have 2x squared plus 8. Plus 8. Bracket. Okay. Make that a little bit smaller. Maybe need one more line here. So then finally, I'm ready to kind of finish my problem. So write this out one more time. X squared plus 4 to the 4th power, x minus 2 to the 3rd power. And all the things inside the bracket can now be simplified together. I got 5x squared plus 2x squared is 7x squared minus 10x plus 8. And this one is, sometimes this one could potentially be factorable, but that requires a factor of quadratic. So we'll see exactly how to do that in just a little bit. In the next couple of examples, that is. So this right here is the final answer for this factoring. Again, not too bad. Take out what both terms have in common, and then whatever is left becomes a little bit easier to kind of collect like terms and combine together into a simplified expression. Not too bad of a problem. Something this long and this difficult, right, as the original question, right? The original question is very annoying to work with just because there's a lot of terms here, right? If you think about distributing, if you think about multiplying that out, it's a very tedious thing. But if you perform this factor and then you get to the end result here, this becomes easier to work with, right? In terms of finding the zeros, in terms of doing really a lot of algebra expression, the last expression is usually a little bit easier. So definitely worth your time to learn this. Definitely worth your time to practice that a little bit. Okay. Moving on to the next part, where we actually working with actual factoring into the quadratic. The majorities are not too bad, assuming you spend the time. So we're gonna solve for this, but of course our method is focusing on the factor, right? Here we go. When you have a triple term, right, this becomes difficult because it's no longer about finding what they have in common, because chances are there's nothing in common. I mean, look at a 3a, for example. There's nothing in common of these three terms. And to factor this, we got to use a little bit of a trick, right? So the way this works, there's really two different problem types here. We'll do A and B, the same problem type, and then C and D later for different, slightly different work. The key here is the first coefficient, right? The leading coefficient of this polynomial. Both of these, A and B, are 1. Actually, this is called a monic polynomial, but that's not too important here. The leading coefficient is 1, means we can use the simpler method of factoring here. Is we just focus on the last constant term, right? Last term that doesn't have any x's. We focus on that, and we're simply gonna find all the factors of 6, or 2 factors of 6. So 2 number multiply equal to 6. Well, that's fairly easy. 1 and 6, maybe -1, -6, right? 2 and 3, -2 and -3. So that's very straightforward. And the question we're asking ourselves is, which one of these factors, pairs of factors, I should say, add up to the number 5? The number that's multiplied to the x, to just 1x. Okay, so in this case, the 5. Well, there's only one pair that adds up to 5, and that's this pair. So the factor is just x plus 2, x plus 3. That equals 0. I'll just copy and paste here for now. But again, the factoring part is just 2 and 3 coming directly from this 2 and that's 3. And once I have it factored, this is easy solutions here, right? We use zero divisor property, set that equal to 0, x plus 2 equals to 0, minus 2 on both sides, I get x equals to negative 2. Similarly, set that equal to 0, x plus 3 equals to 0, minus 3 on both sides, x equals to negative 3. So these are the solutions here, right? But again, once the quadratic is factored, you can get there fairly easily. So the key technique still here is to focus on the factor. Take a look at this one more time for part B, right? Again, because the leading coefficient is 1, we just focus on that last number. And this one has a little bit more, so let's take a look. Oops. Negative 18. Some of the factors, right? 1 and negative 18, negative 1 and positive 18, 2 and negative 9, negative 2 and positive 9, and then I guess 3 and negative 6, negative 3 and 6. 4 doesn't divide 18, 5 doesn't divide 18, and 6 is already I already have it. So as soon as you have a repeat, right, you don't have to go try anymore, right? It means you kind of covered them all. So here we go. We ask ourselves, which one of these add up to the middle number, which is negative 3? And again, there's only one. If it's factorable, right, there's only one, which in this case is actually this one right here. Okay, so the factor is just x plus 3, x minus 6, and then the equal 0, copy and paste. Again, we'll just focus on the factor here. Once we got the factor, right, both of these answers comes out fairly easily. Set that equal to 0, you get x equals to negative 3. Set that equal to 0, you get x equals to 6. So the two answers, again, comes out fairly easily once you factor. And that's the factoring is what we're focusing on. So these two are the easier case of factoring. Let's go ahead and see some of the harder case, right? In the following example, C and D, here, this is the harder case because the leading coefficient is no longer 1, right? For C, the leading coefficient is 3. For D, the leading coefficient is 4. So this one requires a little bit more complicated technique. And what I would do here is to show you a methodical way of doing this, but definitely not efficient. Is a way that can be done if you just follow my steps. You can basically do all of these factoring, assuming, of course, the quadratic is factorable, but it's definitely not efficient majority of the time, that is, right? We want to practice factoring mostly because we want that efficiency. So what do? I'm going to introduce you another method after this, which is the method of guess and check. Doesn't sound as fancy, but it will be efficient. That's the method where you have to practice to get really good at. Okay, but it's always a good, start to have something that, have something concrete that you can always perform and get the factor without having to, do hard guess and check. Anyways, let's see part C first. Because the leading coefficient is no longer 1, here I can't just focus on the 4, the negative 4, and then find the factor of the negative 4. I actually have to take the leading coefficient as well. So I want to take both of these numbers, and multiply them together. Put the arrow the other way around. And multiply them together. 3 times negative 4, and that's going to give me negative 12. This new number is what I want to factor. So negative 12, again, break it into a bunch of factors. So 1, negative 12, negative 1 and 12, 2 and negative 6, negative 2 and 6, 3 and -4, and negative 3 and 4. And again, the next number would be 4, so I already have it here. So once we got the factor, we're gonna ask ourselves the same question: which one of these add up to that -4, right? And again, there should only be one, right? Assuming that the quadratic is factorable, and that is right here. Okay, the 2 and the -6. Now, the way this works, right, this is where it gets complicated, because previously, once we identify which pair of the factors of your number add up to the middle number, you can just conclude the polynomial factor. It's not as simple here. What we're going to do is we're going to copy and paste the first and the last term, the one that I kind of already used. So 3x squared minus 4. Go ahead and leave this 0 here as well. And then we're going to break the middle number into the two factors that I found. So 2 minus 6, right? So I got plus 2x minus 6x. The 2 and the 6 is what I'm working with here. Okay? So what I'm saying here is break the middle term here, right? Break that middle term into the two factors that I found from the previous steps. Now I have a 4-term expression, right? I have a 4-term expression. What's nice about a 4-term expression is you can choose to factor by grouping. So focus on the first two and then focus on the second two. Okay, so let's go ahead and do that. Focus on the first two for now. We're going to perform factor by grouping just like we did for the first two examples here. What they have in common is just a factor x, right? The variable x. Once I have that, I ask myself, what do these have in common? If I take out the x from 3x squared, I got 3x. If I take out x from 2x, I have a 2. And then technically, I will have, I'll put a little plus here just to kind of separate the two terms here. And now let's focus on the second one, right? The second two terms. What these have in common is actually a negative, and then 4 and 6 both have a factor of 2. So I can take out a negative 2. And now what I have left, negative 6, take out the negative 2 is 3x, and then negative 4, take out the negative 2 is 2. Again, just write the 0 there, copy and paste. Now what I have is these, again, two factors here, right? Two terms here, focusing on, coming from the first two term of my previous line and the second two term of my previous line. But now what I see is I once again have a factor or a term here that is that showed up in both, right? Namely this 3x plus 2. This is something that both of these have in common. So let's go ahead and write that out. Factor that out. 3x plus 2. Once I factor that out, right, this is very similar to example 1 and 2 here. Once I take that out, we can see that, well, my first term has a x left because I took out the 3x plus 2. And my second term has a minus 2, right? The positive and negative just kind of combines to one negative. Okay? Or plus negative 2 is the same thing as minus 2, right? So this is something that I end up getting. And of course, there's nothing you can simplify with the x minus 2 here. So that is actually your final answer. So 3x plus 2 times x minus 2. And that's, again, equals to 0. Once I have the factor ready, right, the rest is easy to solve. If you set that if you set that equal to 0, you get x equals to negative 2 over 3. And if you set that equal to 0, you get x equals to 2. So again, the solving part here is not important. The important part is the factoring, right? So anyway, so this is the methodical way of factoring. Now, the thing that I do want to address, I think maybe some of you might be concerning, is this is the choice of factor of negative 12 that eventually lead to basically this part, right? The breakdown of the middle term here. So these two. What if instead of putting 2x minus 6, I put negative 6 plus 2? Are you going to get the same factor? Basically, what if you didn't write it exactly like I have it here? And turns out you will get the same factor at the end here, but the middle steps might look a little bit different. So ultimately, your answers are gonna still look exactly the same, because turns out factoring is unique, right? There's only one way to factor a polynomial, a quadratic, into two terms here, and it doesn't matter whether you choose 2 and negative 6 or negative 6 and 2, you will get the same answer, although the middle of the process might look a little different. Okay, let's do this one more time. Let's practice this again. Here we got a leading coefficient of 4, so we're going to take that number and then multiply it with the constant term. So 4 times 15 equals to 60, and this will have a couple of a couple more factors here. So let's take a look. 60, 1 and 60, negative 1 and negative 60, 2 and 30, negative 2 and negative 30, 3 and 10, negative 3 and negative 10, 4 and 15, negative 4, negative 15, 5 and 12, negative 5, negative 12, and 6 and, oh, I derped there earlier. 3, of course, and 20. Derped. And 6 times 10, and negative 6 times negative 10. 7 doesn't divide 60, 8 doesn't divide 60, 9 also doesn't divide 60, and 10 shows up here already. That's it. So that's all the factors, but boy, that's a lot of factors. That's okay though. We're looking for one that add up to negative 16, right? And again, we got this. Okay. Usually, doesn't have this many factors, but hey, in case it does, now at least you see an example about that. Okay. So I'm gonna go ahead and break the middle terms. Here, let's go ahead and copy and paste that first. So 4x squared plus 15 equals to 0. And then the negative 6, negative 10, so negative 6x minus 10x. Okay, so factor by grouping, focus on the first one. What I see is I have a 2x in common, so 2x in common. And what I have left is 2x minus 3, 2x minus 3. For the next one, I'll go ahead and put a plus just so I can, separate the two here. At first glance, what these two have in common is just the number 5. Let's go ahead and do that first. Right, what they have in common is just the number 5. But then if I take out the constant term, 5, I have a negative 2x plus 3. And the 0 part is just copy and paste. The problem here is now these are no longer the same term. So you can't just factor that out. But we recognize they're actually pretty close, right? They're actually pretty close. So the first one is 2x minus 3. The second one is negative 2x plus 3. So the only thing different is their sign for both of these terms, right? For both 2x and the 3. The only thing different is the sign. So what I'm going to do here is to keep the first one the same, 2x minus 3. But then the second one, I'm going to factor out another negative 1. And when I take out the negative 1, again, think about dividing by negative 1, right? The negative 2x divided by negative 1 is 2x, and the positive 3 divided by negative 1 is negative 3. That's how I'm going to get the other terms. So now these are the same thing, so I can factor that out. So I got 2x minus 3, and then inside the bracket, I have the first term I got 2x left, and then the second term, 5 times negative 1 is negative 5. So I got the second term here. Okay, and again, that's the factor that I got finally, so let's go ahead and write that out. I mean, this is already written out, but let's go ahead and do that. So 2x minus 3 times 2x minus 5 equals to 0. And to get, again, the rest is easy to solve. So set that equal to 0, x equals to 3 over 2. Set that equal to 0, x equals to 5 over 2. Okay? Again, the factoring, the final solution part is really not the most important here. It's the method of factoring. And as you can see, what I was saying earlier, right, before we started this example, these methods are methodical. If you just follow along with this, there's almost no guess and check, right? There's actually 0 guess and check here. And these will always kind of yield out the right factor, again, assuming the quadratic was factorable to begin with. You can tell whether it's factorable or not in this step, right? If you cannot find a set of factor of 60 in this case that add up to the middle number, which is negative 16 in this case, then this quadratic is not factorable, right? Not factorable, in the sense of in the sense of integer factors, that is, or fractional factor, that is. Okay, so this method is methodical, but again, kind of tedious, kind of long to write out every single time. So it's not efficient, right? It's not efficient, but it will get to where you need to be. Okay, now how do we do this type of problem as a more seasoned math student? Well, we're gonna guess and check. Doesn't sound very seasoned, but let's go ahead and see how that works. So there's various presentations online here. You can look these up, and there's a bunch of different quote unquote way of factoring, but it turns out almost none of them are actually method of factoring. They're more of presentation of factoring, right? They're more how should I say this without sounding so bad? They're more gimmick, basically. They're more out there for presentations for the eyeballs. Okay, and honestly, this video is no different in this aspect. I'm gonna choose one of these methods. They call it the box method, whatever. Okay, this is just more of a way for you to visualize this guess and check. So the way I have in mind for number 4, as you can see, 4a is exactly the same thing as 3c. And this is definitely done on purpose just because we already have the answers for these. We can kind of double check. But leveraging from that is we can see, going back to 3c real quick, leveraging that is we can see the answer of 3c in terms of factoring looks kind of like this, right? 3x plus 2, x minus 2. So we can kind of see the format, right, of this factoring. So it kind of looks like this, right? Something like blank x plus blank, and then blank x plus blank, right? I mean, we see the answer is 3x plus 2, x minus 2, right? But that's just another way of saying like 3x plus 2, 1x plus negative 2, right? I mean, we know the answer should be that. But without even knowing the answer, we should at least see the format should look something like this. Okay? And we can identify where these numbers are coming from. So the first two terms have to be factors of this 3x squared. And then the last two terms have to be the factor of that negative 4. These essentially come from the concept of foiling, right? Yeah, we know how foiling works. So the way we're going to do this, right, just what the box is for, is we're going to guess these blanks. We're going to guess these blanks. We should put 0 there. Okay, we're going to guess these blanks. So the first box, so the first blank are numbers that goes into these two boxes. That is the factors of 3x. 3x squared, right, the first term here. The good news here for this particular example is that 3x squared, that is, 3 only have exactly two factors, 1 and 3, because 3 is prime. So what I can do is just go ahead and fit that into the box, because that's the only possible way I can have, right? I can change one. I can put 1x first and then 3x second, but ultimately the same idea. So in terms of guess and check, I can already fit the 3x here and then the 1x there. Now, the last box requires that it requires to be the factors of negative 4. So that needs to go here. And this is where the guessing part, right, the guess and check part is going to show up. Okay, so we want to input the factors of negative 4 into this box. Okay, and now again, we know the answer is already 2 and negative 2, but even then, there's a choice here, right? But let's say for the sake of example, you choose to kind of do 1 and negative 4, right? Both of these are factors of negative 4. So what's going to happen here? Well, we're going to connect the box, right, and then find their multiple. So in this box, we're going to do 3x times negative 4. That's going to be negative 12x. And in this box, we're going to do 1x times 1, which is, well, 1x. And then we're going to add these boxes in the middle together. And in this particular case, I get negative 11x, which is not the number I'm looking for, right? I need negative 4x. So I know from here that this is not the right choice. Okay, so this is where the guess and check way happen, right? So we're going to go ahead and repeat this process essentially over and over again until we get to the right factor. So let's go ahead and see one more example here. Okay, so that one doesn't work. I technically should also have to flip it around just because these boxes are not the same. The pink box are not the same here. So not only I have to try 1 and negative 4, so I try 1 and so if I try 1 and negative 4, it doesn't work. I have to flip that around too. I have to try then negative 4 and 1 like that, right? Let's just try that real quick. 3x times 1 is 3x. 1x times negative 4 is negative 4x. If you add that together, you get negative 1x. Again, not the right factor, right? Not the right term that we're looking for. Okay, so I know 1 times negative 4 right? After trying both of these, I know 1 times -4 is not going to be the right choice. How about 4 times -1? Play that same game, right? 3x times -1 is -3x. 1x times 4 is 4x. Add that together, you get 1x. Not what I'm looking for. So that's not the right choice. So I flip both of these, -1 and 4. Now perform this operation one more time. 3x times 4 is 12x. 1x times -1 is -1x. Add that together, I get 11x. Again, not what I'm looking for. Okay, so after you try the factor of -1 and 4, all the possibilities, right? You realize that's not going to be the right choice. So you got to factor -4 another way. How about -2 and 2? Well, 3x times 2 is 6x. 1x times -2 is -2x. Add that together, I get 4x. So close, but no cigar, right? Not what I'm looking for. So now my only option left is to flip these. So how about 2x and negative, 2 and -2 here. Okay. Finally, we see 3x times -2 is -6x. 1x times 2 is 2x. Add that together. Finally, I got -4x. It's always going to be the last one you try, right? Assuming again your quadratic is factorable, right? It's always the last one you try because, well, after that you stop trying. Once you got it, you stop trying, I suppose. So, anyways, as soon as I see that the result of this kind of method of guess and check gave me what I wanted, I have my factor, right? So the factor here is 3x, and then plus 2, and then 1x minus 2. Basically follow the color coding of my factoring there, right? So that's essentially the concept of the guess and check method way of doing this. It is more efficient because, I mean, I have to write all these down. I have to say out loud for you to see it for the first couple of times. But a lot of times you can perform these operations in your head fairly easily. So we can see that this factor eventually will get more and more efficient as you practice more and more. And the important thing here is to recognize that this box, right, this 6 box, well, 6 box, I don't know what else to call it. It doesn't really contributing to your factoring other than a way of thinking, right? Other than a way to present your work. There's gonna be a lot of that online. You're gonna see it, but none of them is really gonna be a way to help you factor. You still have to be the one practicing how to kind of match the numbers together to get the right um, terms that you're looking for, right? Specifically the middle term that you're looking for. So definitely worth your while to practice this. And let's see one more example, but you know, you gotta spend a lot of time practicing this on your own. All right, for this one, for part B, you can pause the video, try this yourself for a quick second, and then let's go ahead and write this out. Okay. uh, for me personally, instead of writing this box every time, which is really not the most meaningful way of showing work, um, or perform this factoring technique, I actually just write out the factor itself, right? And then just kind of imagine the blank x plus blank type of deal. So this is essentially me writing down the box, right? That helps me to think. And I typically start with the first term here. I start with this, right? Um, but to be fair, you should kind of always start with a number that's easy to factor. What I mean here is, here I got a number 5, but the constant term is number 8. So 5 has less factors than 8, because 5 just 1 and 5. Okay, so technically that's probably the better way to start, but I personally like to start just with the first term. Okay, what that means here is, in this particular case, 5x squared, right, factors into 5x plus 1x. Okay, and this 5 and 1, I fix that first, and then I kind of mentally move around the number 8 to double check my factor. In the perspective of the box, that means I go ahead and put 5x and 1x here first, and then just kind of make sure I kind of fix it. Okay, and then I move out to check for the factors of 8. Yeah, so factors of 8. So double check that real quick. We can do a bunch of different things. Maybe we'll do 2 wrong examples, and then we'll just jump to the right one. So how about 1 and 8? 5x times 8 is 40x. 1x times 1 is 1x. Add that together, we get 41x, which is definitely not 14x, right? So that's not the right choice. Let's move on to the other one. You should, again, flip that around. We should do 8 and 1 also. You know what, actually, why don't I do that? You should do 8 and 1. You should do, like, basically all the possible combinations, right? So 8 and 1 here. And then, if none of these factors work, then your quadratic is not factorable. So 5x times 1 is 5x. 1x times 8 is, well, 8x. 5x plus 8x is 13x. Close, but no cigar, right? So this choice is not the right one. Kind of go through the motions and check for all of the other ones, but it turns out the answer here is -4 and -2. And again, that does come from practicing, and you can get more efficient at it. You can notice a couple of patterns, different patterns here. So it's helpful to do a little bit more practice. So 5x times -2 is -10x. 1x times -4 is -4x. And if you add that together, you get -14x. Okay? And that's going to be my final result for the factors. So here we go. 5x minus 4, 1x minus 2. Okay? And then if you want to write that a little bit more cleanly, 5x minus 4 times x minus 2. Okay, so that's the factor right here. All right, let's see some more challenging version of this. This is particularly more challenging just because the factors of 4 is 1 and 4 or 2 and 2. That's why I gave you kind of 2 boxes here, right? So again, we kind of play the same game here. Let's just write on the bottom. Blank x plus blank. So now it's not obvious which version to use. Right? It's not obvious which version to use. Again, though, 4C is the same as 3D. Okay, take a look. It's the same thing as this one right here. Okay, so we did this already. We know the answer. Again, I just, obviously I want you to see that this method, of course, can solve the previous questions. So let's try the wrong one first. Why not? So if we have it as 4x and 1x, okay, 4x and 1x, you'll realize no matter what you use for the factors of 15, how about I say 3 and 5, you're not going to get the right answer. So let's do this real quick. 4x times 5 is 20x. 1x times 3 is 3x. If you add that together, you get 23x. And again, no matter what choice you make for these two, right, factors of 15, you're not going to get to the right one. So the idea here is you kind of go through all of them, and then you see, hey, look, I'm not getting the factor, the term that I want, right? Namely the negative 16x. So after you try all your possibilities, you then realize, okay, maybe the very first two factor is not the right choice. So you go back and basically break this up in a slightly different way. So how about 2x and 2x? Okay, so once you do that, again, you can start choosing factors of 15. You know, for the sake of example, let's go ahead and again do a wrong one. Just 3 and 5, or you can try 1 and 15, whatever, because we know the answer to this, right? Okay, so you do 2x times 5 is 10x, 2x times 3 is 6x, and if you add that together, we get positive 16x, which is not the same as negative 16x, right? So I know this is the wrong factor, but then I think to myself, well, that's a kind of an easy fix, right? So instead of checking for more, like a different combination of factors, I want to just check these two factors, the negative version, the same thing, right? So negative 3 times negative 5 also equals to positive 15. But then if you make this choice, 2x times negative 5 is negative 10x, 2x times negative 3 is negative 6x, and if you add them together, you get negative 16x. The point here is, you know, even if the guess and check way kind of increase, right, nearly doubling the amount of guess you have to do, if the leading coefficient is a number that has a lot of possible factors, right? In this case, 4 has really two different versions of the factors here. But anyways, once we you know, found the right choice, we can then kind of write in our final answer. 2x minus 3, 2x, oops, at the x, 2x minus 5. Okay, and again, we know that this is the right factor just because we kind of already did that before. All right, so guess and check way, slightly bit more efficient. Now, I will say a quick disclaimer. If the number is too big, if the number, you know, give you a lot of factors, right? If the number give you, or a bigger number, like, you know, 96 or something like that, where you have enormous amount of factoring, this method is sometimes not as efficient as just go ahead and do the methodical way. Just the methodical method is a little bit long to write down, but again, there's no guesswork, which ultimately might be a better thing for you guys. Okay, so one last example. I know it's taking a second, but like these are important techniques, so practicing them doesn't hurt. Okay, so this right here, same idea. Blank x plus blank, blank x plus blank. Kind of an important deal here. Again, the factors of 6, say 6x squared, right? We can either do, let's do 3x and then 2x here. Actually, let's do the other one first, just to kind of show you the examples here. 6x and 1x, right? And then here, factors of negative 3. The issue here, again, well, actually, instead of saying issue, this might be a good thing here. Negative 3 doesn't have that many factors. So negative 1 and 3, for example, is a factor. And then positive 1, negative 3 is a factor, but that's it, right? So this is pretty easy to do. And you can kind of do that. So 6x times 3 is 18x. And then x times negative 1 is negative 1x, right? If you add that together, we get 17x. That's not what you're looking for, okay? And turns out, again, if you make the different choice between negative 1 and 3, or 1 and negative 3, you're not going to get the right one. So we move on to the other possible factor. So 6x squared factors into 3x and 2x. And from here, I can then make my guess one more time, right? So, and let's just jump to the answer here. So it's going to be 1 and 3, negative 3, that is. So here, 3x times negative 3 is negative 9x. Got the thing. And then 2x times 1 is 2x. So now if you add these together, you get negative 7x, okay, which is what we're looking for. So that's the right factor. Okay, and just fill it in. So 3x plus 1, 2x minus 3. Okay, so that's the factor here. Again, the box doesn't really help you on the factor. You still have to mentally do the guess and check way yourself, but it provides a little bit of a guidance, right? Or at least a way for you to show it or write it down for your own good. I'm not gonna require you to draw the box every time. I think this is silly. If you practice enough so you can factor it correctly, you can just basically jump from here to the answer right away. And it is generally acceptable that you can perform the factor. Now, of course, you gotta make sure you have the right one, right? If you make a mistake, even just a little bit, your factors are wrong and you're not gonna get the right answer. So I suggest after you factor, right, using the guess and check method, even though you already guessed and checked, right, the check part is important, it's just kind of nice as an extra layer just for yourself. Again, also more practice to kind of take your factor and just try to FOIL it out and see if you get back to the original, right? So we got, in this case, 3x times 2x, which is 6x squared, right? Just standard FOIL. 3x times negative 3 is negative 9x. 1 times 2x is 2x, and then 1 times negative 3 is negative 3. And again, after foiling, we do get back to the original question. So I know I've done it right. Okay, just a quick check, especially the early couple of times that you have to factor, be able to check and be extra confident that your answer is correct is really efficient. It's really meaningful, I should say. Okay, so that's kind of it for this kind of factor. I do want you to practice that a little bit. Let's go ahead and move on to the next couple of questions. Now that we have these kind of factoring techniques, the next couple of questions should be a lot smoother. Um, by the way, technically, factoring a quadratic uh, is not in some sense delivered uh, as part of this class that takes this long. I'm breaking this down in further detail just because I know that this is potentially a weak point for a lot of people. Okay, so I know it's going on a little bit longer than it needs to be, but you can hopefully benefit from the breakdown of these kind of factors. Now, let's see what that gave us, right? Once we're familiar with this, we can do guess and check, or we can do the methodical way here. It doesn't matter. But for example number 5 here, for problem number 5 here, uh, 5a here, 6x squared plus 7x minus 5. I will always do the guess and check way because again, that's the most efficient. And for me, I will guess the 2x times 3x here. So 2x times 3x, right, for the 6. And then I move around with the negative 5. And it turns out it's going to be positive 5 minus 1. So again, I'm doing all these kind of guess and check the way I did it at the very beginning, right? In the previous example with all these boxes, but I just kind of imagine those boxes in my head instead of having to draw them out. double check this real quick. -1 times 3 is -3x, and then 2x times 5 is the 10x. And of course, that adds up together to be the 7x. Okay, so this is my factor. Similarly, for b, I got 3x and then just 1x. Okay, I don't need to do anything else here because 3 is a prime number, so the only factor is 3 and 1. So I just need to move around the -6. And again, with some practice, you can probably do this too. It's going to be -3 and then +2. Okay, a quick check gave me 2 times x is 2x, 3 times -3 is -9x, and then -9 plus 2 is -7. So that is my right factor here. Okay, so it's really just all about efficiency. The better you are at practicing, right? The more you practice, really, the better you are at doing this. And it's really going to simplify your problems and solutions quite a bit. Okay, now let's go ahead and do the last problem for this video. Uh, um, I know there's a lot going on already, but let's take a look. This one is a special factor. This is kind of nice and fairly simple if you remember this formula here. It's called the difference of squares, right? We will be using this here and there. Again, just because it's nice and simple. Uh, we have a squared minus b squared. The minus, of course, is the difference, right? And then a squared and b squared, they're squares. So difference of squares. Okay, that's where the name come from. It's not the most exciting name here. But basically the idea is if you see a squared minus b squared, it kind of factors into a minus b times a plus b. So a is here, right? The first term. And then for b, you just do minus b and plus b. Okay, that's all there is to it. So let's quickly go through this example. So I got x squared minus 9, right? So I need to write that as square minus square. Well, that's pretty easy. So x squared is already a squared, but 9 is 3 squared. So I got x squared minus 3 squared. So that's my a and b. So the factor simply becomes x minus 3, x plus 3. So a squared, or a minus b, and a plus b. Okay, that's all there is to it. For part b, 4x squared, I need to write that as this perfect square. Well, that's 4x squared is 2x quantity squared minus 25, which is 5 squared. Oops, 5 squared. That means my 2x is a and 5 is the b. So then the factor becomes 2x minus 5, 2x plus 5. The 2x is the a, and the 5 is the b. You can pause the video here to try C and D. Okay. Go ahead and write this out. 9x squared is also known as 3x quantity squared minus 16y squared is also known as 4y quantity squared. So that's my A and that's my B. So the answer is 3x minus 4y, 3x plus 4y. Right? So A minus B, and a plus b. Okay? Very easy factor here. And last but not least, the last problem here, I got ax squared y squared minus 98z to the fourth. There's a lot of things happening here, but one of the most kind of the first thing we notice really one of the most troubling things we notice is that 8 is not a perfect square. Neither is 98, right? There's actually two ways to go by this. One is just we kind of brute force it. Well, 8 is a perfect square in terms of real numbers. Namely, 8 is a radical square. So radical square root of 8 square. And that's really true for any positive numbers, right? So we can do that, play the same game with 98 as well. So 98, right, square root, and then square. We can definitely do that. And then you kind of, this problem behaves very similar to other problem before. In this particular problem, though, we can actually do something first. We realize 8 and 98, while they're not perfect squares, they have something in common, namely 2. So I want to factor out 2, and then the first term becomes 4x squared y squared. Second term becomes minus 49d to the fourth. Right, as soon as I take out that 2, I actually do see the remaining parts are perfect squares. So I'm going to go ahead and do that. So leave the 2 alone here. 4x squared y squared is 2xy quantity squared minus 49z to the fourth is 7z squared squared. And that becomes my A and B. So in terms of factoring, this is equal to, again, the 2, you have to write that out. I'll use a bracket instead of a parentheses here, just to kind of distinguish. I'll have a 2xy minus 7z squared, and then 2xy plus 7z squared. That is my factor. Again, my A is this, my B is this. Okay? And that's it for this kind of problem. So really not too difficult of a problem. Different square actually shows up quite a bit in algebra. And it's really not a bad formula to do. And in later sections, we are going to talk about other, special factors, but we'll go ahead and leave that for the future. Okay, so that's it for this video. See part 2 for the rest of this note.